in. Like they not
Oh,
locked in like me.
they're
Yeah.
not. All right, let's go. Let's go. Let's go. All right. Gonna go live on TikTok. People on TikTok have been missing the lives.
Oh.
Math, well, physics and math lives. So I need somebody on TikTok watch. Stand by. Let me know how the TikTok is looking.
Looking good.
Let me get that chat running. My classes will reach the next level when I could like do live memes.
Memes?
Yeah, like okay, maybe in a class I'll be like and then like the ISO speed would like show my face.
Oh yeah, yeah, yeah. That would be cool.
Yeah. People keep saying CXC done. Like all they forgetting and have other people that had to write CXC or what? Dog. Not just you writing CXC and all you had to understand that. It's not just you writing CXC. So much people writing
Starting
CXC.
to think that now that them finish CXC the world over, nobody else have to write after.
That is what I feel. That
They
is what I
don't
feel.
understand.
That is a scary mindset, you know. Like sometimes you have to step back and think about other people. If you know what I mean. Alright, so it's showing good, it's showing good. Somebody say, like next year not coming. You know who we missing in this live? Eden. We missing
That
Eden.
is nothing, but it's good to prep now for CXC because
Yeah,
simple and easy.
this is the prime time to prep.
Exactly. I wish I did prep earlier for CXC.
So you wrote exams and got your results.
Yes, sir. I wrote exams this year.
I feel like I hear your voice before. Like you were in my
Yes, I
live.
was in your classes.
I see, I see. You gonna write back
Yep.
maths?
No, for maths
Say that
and
again?
physics.
You get through with maths and physics?
Actually, no, because
Nah.
I started late. I got five in maths and I want to do it over, and I got four in physics and I want to do that over too.
Okay, well I look forward to seeing you. I will try my best to help you.
Okay,
Yeah.
so I told my mom you're going on ask you for assistance because I did join your class on them late.
Mm-hmm.
And my maths teacher wasn't like, he wasn't really teaching me in school. So yeah. Because in we school, like only one person alone passed maths.
That is what school is that?
Everybody else got five in maths. And I was like,
That is crazy.
yeah, only
But
one person. And the person that passed, I think she got three in maths. So
that
yeah,
is
I
that
went and do it
is
over.
that is genuinely concerning.
Just because he told us that he wasn't going to teach us the rest of the syllabus because some children we was looking like we wasn't willing to learn.
What?
Some children wasn't looking like they were willing to learn, so he never teach us the rest of the syllabus.
What kind of thing is that?
I don't know.
Um,
He crazy.
sounds so. Spidey, sir, you never reply to me on WhatsApp. Send my message again. All you had to understand is I have like 100 chats, like per day. It's be hard. It's be hard to keep up with the constant messages. It is. Alright, so I'm going to do some physics tonight. And you all are going to see how cool physics is and how applicable it is. Like you all think a lot of people think that physics hard, but when I show you guys how easy physics is, you're gonna be like, wowza. Nah, for real, for real. So let me go. And I built something especially for you guys. Alright, so the topic we're gonna be looking at today is something called moments. Moments. Do you all have any idea as to what moments is? Moments. What's moments? What's that?
I mean, when I hear moments, I think force times distance.
Right, you hear force times distance, but I want you guys to think of it a bit differently. A moment is the turning effect. Is the turning effect from applying a force to a body on a that's on a pivot. Now you're probably saying, what? What do you mean by turning effect, boy? Turning effect from applying a force to a body? What is that? Well, let me show you how simple this is, right? Now, when we're talking about moments, you could have two types of moments. You could have clockwise moments or anti-clockwise moments. And it really depends on when you're pushing, right? You'll see what I mean just now by that. But when we talk about moments, we're talking about the turning effect, and you could have two main kinds. You could have clockwise moments, or you could have something called anti-clockwise moments. You dig? Clockwise moments or anti-clockwise moments?
Yes, sir.
I should probably state that this means clockwise. I should probably say that. And what does ACW mean?
Anti-clockwise.
Again, you're probably scratching your head. Don't worry, I'll make it make sense for you just now. Give me a chance. So, first things first, all you had to understand what is clockwise and anti-clockwise. Now, I know the future generation, like all the new kids, all they don't know what a regular clock does look like. You all don't know what an analog clock does look like. How much of you guys know what an analog clock does look like? Let me know. How much of you guys know what analog clock does look like?
Me?
That's good, Virginia. People on TikTok, how much of you guys know what an analog watch does look like? Do you all know what an analog watch is? I see somebody say yeah. Draco say yeah. Cool. So the analog watch is the one that has numbers. You know, like you have 12 here. Where does that have, Virginia?
3,
What does that have here?
6.
And over here there's a 9, and
Yes, sir.
so the long hand of the clock, doesn't it go in this direction?
Yes, sir.
Let me run it back again. So guys, let's track the motion of the clock. Alright, we're tracking the motion. Oh, you see that, right?
Yes, sir.
Hope all you clock that. You see what I did there. But that's where the term clockwise came from. You could look at the hand of a clock and see the direction it's going in. That tells you what clockwise is. So the clockwise direction is this. This is the clockwise direction. Does everybody understand that? That is the clockwise direction. This is clockwise. Let me know if you guys understand that. Yes or no?
Yes, sir.
Right. So this is clockwise. Let me just run it back again. So guys, would that be clockwise? Talk to me. Let me know, would that be clockwise or would that be anti-clockwise?
That would be anti-clockwise.
How about the other people on TikTok, people on YouTube? Would that be clockwise or would that be anti-clockwise? What do you all think? Or you think I'm joking? This is a serious thing to understand, you know? This is a serious thing to understand. I wonder if... Yeah, this is anti-clockwise. What would this be, guys? What would that be?
Clockwise.
Right, so this is clockwise. Okay, so if clockwise is like that, then anti-clockwise would just simply be in the opposite direction. So you guys understand that this would be anti-clockwise, yes or no?
Yes, sir.
Good. So this is clockwise. So anti-clockwise would look like this. This is anti-clockwise. Does everybody... Okay, let me know. Like, you had to understand this before we move forward. Does everybody catch this? Yes or no?
Yes, sir, I catch it.
How about the other people in the Zoom? Are they understand clockwise and anti-clockwise?
Yes, sir.
Cool, cool. Let me give you all an example of where you'd find a moment. And remember, a moment is just the turning effect. Simply the turning effect. And you can have two types, clockwise or anti-clockwise. So let's just say you have a seesaw over here. You have a seesaw. You have a seesaw. You're probably saying, sir, where's the pivot? The pivot is a point about which a body could rotate. So guys, you see this point over here? This is physics. This is physics, right? This is physics. Could everybody imagine that if you were to apply a force on either side, it would rotate about this point? Let me know if you understand that. Like, it would rotate about that point.
Yes, sir.
People on TikTok, let me know if you understand that. The plank would rotate about that point. Like, if you apply a force here, the plank would be like that. If I apply a force in this direction, the plank would be like this, but it's rotating about this point. That is the point of rotation. So let me give you all a practical example. So you all could see that I have the Apple Pencil on my finger, right? Are you seeing that? Notice that it rotates about where my finger is. So in this instance, my finger would act as the pivot. So the pivot is just simply where, it's just a point about which rotation happens. Understand that? You don't have to be complicated. It isn't complicated. It's just a point about which rotation happens. Let me write that down. So the pivot is the point about which rotation occurs. Right, and I need you all to understand that there's two names for this. You could call it a pivot, or you could call it a, does anybody know? A pivot or a what?
Fulcrum.
Right, you could call it a pivot or a fulcrum. So they're probably scratching on their head and saying, but sir, I don't see how turning effects could come into this. Well, again, stay with me. So Virginia, imagine you push the plank on this side. What's that going to do to the plank? What's that going to do to the plank? What is that going to do to the plank?
It would sink on that side and raise on the other.
Yeah,
Well,
somebody
it
said.
cause a rotation around the pivot.
Exactly. Guys, do you all understand that if I apply an unbalanced force to that end, it's going to cause the plank to sink over here, it's going to sink down, and over here is going to rise? Let me know if I'll catch that. Somebody said sum of clockwise moments is equal to sum of anti-clockwise moments. Yes, user 420. Yes, that's correct. Right, if the system is in equilibrium. So does everybody, let me actually show you. And by the way, I made a web app to demonstrate this. I'll show you guys that just now. Let me make this pink. So guys, stay with me. You will understand it. Perfect. This is perfect, guys. Wait. Give me a second. I gotta work it like this. So, guys, understand that if I were to apply a force on the left side, it would rotate like that. Could you all visualize that? Could you all visualize that with your own eyes? That if you push on the left, it will want to rotate like that. Let me know.
Yes. Yes, sir.
Nice. People on TikTok. Or they could visualize that, right? Now, let me ask you a question. What direction does that look like? Let's look at it again. So we start off over here. And what is that? Clockwise or anti-clockwise?
Clockwise.
You sure that clockwise?
It's not anti-clockwise.
It's anti-clockwise. Look at it. Look at how it's moving. So it started over here. And when we pushed on this side, it started to rotate like this. Watch. Let's look at it again.
Oh, yes. I understand. I see it.
Are you guys seeing the anti-clockwise? Let me go over again. Right? So we start there. Are you all seeing the anti-clockwise?
Yes, sir.
Yes, sir.
Cool. So if we apply a force on the left hand side of the plank, then it's going to it's going to result in a what?
Anti-clockwise movement.
Right, it's going to result in an anti-clockwise moment. Does everybody understand that? So like if you push down on this side, it's going to cause the plank to be slant like that and go in an anti-clockwise direction. Cool. Let's move on to the other side now. So guys, if that side is anti-clockwise, what do you think the other side will be?
Clockwise.
Clockwise, yes. Let's use a different color. So if I apply a force on that end, let's see what's gonna happen. What happening, guys? It going in our direction. Let's look at it again. You push down. Oh, let's see that. What direction is that? Watch. Let's look at it again. What direction is that? Tell me.
Clockwise.
Clockwise.
Exactly. So by me pushing on that end, it's going to generate a clockwise moment. So that is what I mean by moment. I'm talking about the turning effect. So let me know if you guys are okay with these two concepts. Moment, pivot, and anti-clockwise and clockwise.
Yes, sir.
Cool. Now this system, would you say the system is balanced right now or unbalanced? Talk to me.
Unbalanced.
Unbalanced.
I would say it's balanced.
Oh wait, yeah. Oops.
Guys, if you look at this system, right? If you look at this system, is it slanted in one direction?
No.
No, sir.
No, it's like staying there. It's staying there, right? Let me give you all an example with the Apple Pencil. So I want you guys to tell me when the Apple Pencil is stable. I'm gonna put it here. That's stable. That looks stable for you.
No.
No, sir.
What about over here? Does that look stable?
Oh yes, sir.
Yes, sir. It's a little shaky.
A little shaky, but it's staying there, right?
Yes, sir.
So the point I'm trying to make is, if it is stable, the clockwise movements and the anti-clockwise movements, what do they do to each other? What do they do to each other?
Cancel each other, so cause
Yes, yes, they cancel each other. So guys, if a system is balanced, then the anti-clockwise moments cancel off with the clockwise moments, and it just stays there. It just stays there. So we just looked at the principle of moments. That's literally what we just looked at. And the principle of moments says that, let me write it down. So the principle of moments state that if a system is in equilibrium, and equilibrium is just a fancy word for balanced. Are you with me?
Yes, sir.
Good. Right? So if a system is in equilibrium, balanced, it means that the sum of anti-clockwise moments had to be equal to what?
The clockwise movement.
Right? The sum of the clockwise moments. So people on TikTok, let me know if you all understand that. Like let me know, like, if a system is balanced, that means that the anti-clockwise and the clockwise cancelling off. They cancelling off. So they just remaining there. It's just gonna remain there. Are you all with me? Okay. Let me give you guys, just remember this, right? Remember this, Suma? So the anti-clockwise moments had to be equal to the clockwise moments if it's balanced. Let's look at another concept now. I want you guys, this is the time for me to show you guys the app I made, right? This is the time. I'm gonna show you all the app. Are you ready?
Yes, sir.
Yes, sir.
Check this out. This is real tough. Not gonna lie, this is really tough. Check this out. And this is part of my website. Are they seeing the screen, right?
Yep.
Yes,
Alright.
sir.
So I want you all, I'm gonna remove everything, right? So I'm gonna clear everything. People on TikTok mightn't be seeing this the best. Okay, so right now the system is what?
balanced in equilibrium.
Right now,
Balance.
all they seeing like a preview, no. I'm working on the website still, but I just giving a little sneak peek. So right now, the system is balanced. People on TikTok, let me know if you all agree with that. The system is balanced right now. Congratulations to the person that keeps spamming. Right. Is the system balanced now? Actually, let me make it more. Let me make it more. Like talk to my guys. Are they think that system is balanced?
No,
No.
Right now, it has a what type of moment? Clockwise or anti-clockwise?
anti-clockwise.
Right. So you see, I'm saying here the anti-clockwise moment wins. Right. So guys, if I use say like a lighter load, right? If I wanted to have like, I just want you all to go purely off intuition, right? Where would I have to move that this lighter weight? If I wanted to try to balance, would I move it closer to the pivot, or would I move it further away from the pivot? What do you all what do you all do logically?
Away from the
Further
pivot.
away.
Wow. Let me use something a little more heavier. Probably I use like a tree. Now even that not gonna work. Maybe I could use like a 1 and a 2. Yeah, we're using a 1 and a 2, right? Okay.
We had to wait on Sir to figure out what he wanted.
Right. So guys, right now which clockwise moment wins? Which moment wins, the clockwise or the anti-clockwise?
Anti-clockwise.
Anti.
If I want this to be balanced, should I take this weight and bring it close to the pivot or further away from the pivot? What you all think?
Further away.
Further away.
I had to work on this design, like I had to work on the design, right? But the point I'm trying to make is the further away you go from the pivot, what increases? What does increase?
The clockwise movement.
Yes. So guys, let me try this. So I want you guys to stop me when it's balanced.
Stop.
Oh, look at that. Look
Wait.
at that. It's balanced. It's in equilibrium. So the concept I'm trying to preach is that the factors that affect the moment is going to be the force, which is the weight of the object, and the distance from the pivot. Let me run through that again. So guys, I have a question. If I take this object and I move it further away from the pivot, would the system, what would win? The anti-clockwise moments or the clockwise moments?
The clockwise movements.
Yeah, sure.
Wait, no, the anti-clockwise movements.
And if I bring it closer to the pivot, what would win? The anti-clockwise moments or the clockwise moments?
The clockwise movements.
Exactly. So guys, let me know, do you all think the moment increases when you bring it closer to the pivot or decreases? What do you all think? I'll repeat the question again. Do you think the moment increases when you bring it closer to the pivot or decrease?
Decreases.
It decreases. I'm seeing people saying increase, but that's not true. Watch. I'm gonna move this further away. You see, look at now wins. It now wins. I'm gonna go over that again, right? So right now it's in equilibrium. If it is in equilibrium, it means that the clockwise moments is gonna be equal to the
Anti-clockwise movements.
good. So it's balanced right now. If I take this weight and I move it further away from the pivot, what wins? What wins?
Anti-clockwise.
Exactly. If the anti-clockwise moments wins, it means that when you go further away from the pivot, the anti-clockwise moment had to increase. Look at the number, right? Look at this for yourself, right? What is the moment over here? What is the moment over here, guys?
14 Newton meters.
14 Newton meters. If I move it further away, what happens to it? Does it increase or decrease?
Oh, it increases.
It increases. I probably forget how I asked the question, but I probably asked the question like that, and that's why so much people saying increase. Right? So let me run it back again. The moment increases if you move it further away from the...
Pivot.
Exactly. So let me know if you guys understand that. The moment is going to increase if you move further away from the pivot. Do you guys understand that?
Yes, sir.
Right. So the further away you go from the pivot, the greater the moment is going to be. The greater the moment is going to be. And the heavier the object, the greater the moment is going to be. So the two factors that affect moments is really force and the distance from the pivot. So let me continue where I left off. So the two things that affect moments is really the force and the distance from the pivot. Those are the things that affect your moment, the turning effect. Yeah. The website could drop soon, don't worry. So here's a practical question for you guys. If you were using a crowbar, right? Talk to my guys. If you were using a crowbar, obviously not for nefarious reasons. Give me a second. Talk to me, right? So guys, I have a question. Can you all see that we have a crowbar over here?
Yes, sir.
Wouldn't the crowbar rotate about this point?
Yeah.
So question, guys, question. If you wanted to lift this boulder, would you, like, intuitively, would you push close to the pivot or would you push further away from the pivot? What would you do?
Push further away.
What would you guys do in TikTok, boy? Would you all push close to the pivot or would you all push like further away? I'm seeing a lot of people saying further, and that makes sense. That makes sense. You'll push further away. And because if you push further away, the anti-clockwise moment you're going to generate is going to be a lot more. So I hope you guys understand this example. So the further you go from the pivot, the greater the force is going to be. Right? Hope that makes sense. I'll understand that, right? Like let me know if I understand that.
Like, yes, but not really. Not like completely.
Alright, so Virginia. So the formula for moment is equal to force by distance.
Yes, sir.
If you want to lift this boulder, wouldn't you have to generate a really strong anti-clockwise moment for it to lift up?
Yes, sir.
Now, moment is equal to the product of force by distance. So if you increase the distance from the pivot, what happens to the moment?
It would increase.
Exactly. So if you go further away from the pivot, what happens to your moment?
It would increase even more.
Exactly. You understand?
Okay. Yeah.
So like, let me give you an example, right? Let's just say you were to push here instead. Now let's just say from the pivot to this point over here is 1 meter, and the distance from the pivot to over here is, let's just say, is 0.5 meters. And let's just say using the same force of, say, 50 newtons. Now you know that moment is equal to force by distance, right?
Yes, sir.
So let's check out what's happening over here. So the force is 50 newtons, and how far are you from the pivot?
1 meter.
1 meter. So what's 50 by 1?
50 newtons.
Okay, 50 newton meters. That's your moment there.
Sorry.
If you were to push over here now, your force is the same 50 newtons, but your distance is now 0.5. What is 50 by 0.5?
25 newton meters.
Where gave you the greater moment? Closer to the pivot or further away?
Further away. Okay.
Yeah.
So basically everything is proportional.
Yes.
Okay.
So the moment is directly proportional to the distance.
Okay.
So Virginia, if you want to increase your moment, should you go closer to the pivot or further away from the pivot?
Further away from the pivot.
Exactly. People on TikTok, let me know if you guys understand that. I'm saying if you want to increase your moment, you'll push further away from the pivot. Let me know if you guys catch that. So the further away you go from the pivot, the greater the moment you'll generate. And let me explain. Let me explain an example of that in real life. Talk to me. If you were building a door, and let's just say this is the hinge at the door, right? Tell me, where would you place the doorknob? Would you place the doorknob close to the hinge, or would you place it far from the hinge?
Far from it.
Talk to me, guys. Talk to me. Where would you place the hinge? If I mean, sorry, where would you place the doorknob? You would place it far from the hinge. That's like a practical example of moments, right? Because talk to me. In this scenario, when you're opening the door, doesn't it rotate about the hinge? This is the hinge. Yes, somebody's saying the correct thing. If it's closed, it'll be harder to open. So, Virginia, do you understand that in the example of a door, the hinge is actually the pivot?
Yes, sir.
Yeah, the hinge is actually the pivot or the fulcrum, because that's the point about which rotation happens. And if you want to open a door very easily and you design it smartly, the knob will be as far as from the hinge as possible.
Oh, okay.
Do you guys comprehend that?
Yes, sir.
Yeah, okay, nice. So, cool. Hope everybody understands that. If you were building a door, you would place the doorknob as far from the hinge as possible. And that would make sure that opening the door is easy as possible. You wouldn't place the hinge close to the hinge. You wouldn't place the doorknob close to the hinge, right? That wouldn't make any sense. You want to place the doorknob as far away from the hinge as it could. So does everybody understand that the further away you go from the pivot, the greater the moment?
Yes, sir.
Alright, so let's move on. So is everybody okay with this, right? Does everybody understand that if a system is balanced, anti-clockwise moments is equal to clockwise moments?
Yes, sir.
Right. And what are the factors that affect moments?
Force and distance.
Force and distance. Guys, let me ask you a question. Talk to me, right? Let me ask you a question. So I'm going to give you an example. Now, people in my class, they gonna know about Fat Man Bob, right? So the new people might know about Fat Man Bob. But if I put Fat Man Bob over here, and I put Virginia over here, Virginia, I guess you're not well, you don't
No.
know, right? Talk to me, guys. Tell me, do you think that seesaw is going to balance? Do you think that seesaw is gonna balance?
Nah, sir, flying.
You're flying, right? Guys, and she gonna fly into the sky?
Yeah, sure.
And she gonna fly into she gonna fly off into the sky, right? So who do you think has a greater weight there? Do you think Bob has a greater weight or Virginia?
Bob.
Bob has a greater weight. Now something else I need to explain to you guys. Did you guys know that weight is actually a downward force? Weight is a downward force.
Yes, sir.
Okay, good. Weight is a downward force. It makes sense. If you sit down on somebody and you crush them, well, if Fat Man Bob sit down on you, Virginia, and you're gonna get crushed.
Yeah, for sure.
Exactly. So weight is actually a downward force. How exactly do we calculate weight? Weight is just simply mass times the gravitational strength. Now, depending on where you are, the gravitational field strength will change. Right? So if you're on Earth versus if you're on the moon, the gravity will be different. And of course, if you're in space, gravity is 0. Cool. So does everybody understand that force affects the moment? Let me know if you understand that.
Yes, sir.
Yeah.
Good. So in this scenario, we have Fat Man Bob. So obviously I draw this real bad, right? And I draw this thing real bad. It's not like it don't make sense. Like it would actually look like this. Give me a second. Give me a second, right? This make more sense. Talk to me, guys. Doesn't this make more sense?
Yes, sir.
So both of them are the same distance from the pivot, right? I want you to understand that. Both Virginia and Bob are the same distance from the pivot. What is the only different thing about them? Talk to me, guys. What's the only different thing about them? They're the same
Hi,
distance.
sir. Good night. Good night. I
Good
know
night,
you miss
Renisha.
me.
Of course. So talk to me, guys. I'm telling you that the distance from the pivot is the same. What is the only difference?
Well, the force, but in this case weight.
Exactly. Right. So the mass, I'm saying, Bob has a greater mass. If he has
Yeah,
a greater
Bob
mass,
faster than the teeny little person there.
exactly.
Bob
Because
is a big guy.
yeah, so because Bob is a big guy, his weight is gonna be more. So does everybody understand that the two factors that affect moments is the weight and the distance from the pivot? Let me know if you guys understand that.
So
Yes.
sorry to disturb your class, but you can tell me why I'm so far. I wasn't told. I wasn't told. So
Um,
tell me why I'm so far.
I just explained the concept of moments and a seesaw. You didn't miss too
Oh,
much, don't worry. All right.
all right.
So the factors that affect moments are what? Remind me. What affects moments?
Force and distance.
Right. So
Yeah.
guys, when I'm teaching a class, I don't want students to just memorize things. I don't want that. I want you all to understand how and why. I want you all to use your brain and intuition to think. So, what affects moments is force and distance. And this will come to no shock, but the formula for moments is actually force times distance. Moment. So, if you want to calculate the moment, it's just simply the force by the distance. So M would be equal to FD. And I can't stress this enough. The distance is with respect to the what?
I'm not sure. Moment? I don't know.
Nah.
Pivot?
Look at the example. Alright, so the distance from the pivot. Let me give you another example, right? So Virginia, when I gave you this example over here, what was the pivot? What was the pivot in this question? Was
The
over here,
area.
right?
Yeah.
Right, and I said the further you go from the pivot, the greater the what? The further you go from the pivot, the greater the what?
Moment.
Exactly. Now I'm measuring that distance from the what?
Pivot.
The pivot. Exactly. You always measure the force from the
Pivot.
exactly. Yes, I cannot stress that enough. The distance is from the pivot. It is always from the pivot. Alright, cool. So let's just do a quick recap. There are two types of moments. What are the types of moments we have?
Clockwise moments and anti-clockwise moments.
If a system is in
I was gonna
equilibrium,
say CW and ACW.
right? So CW means clockwise and ACW means anti-clockwise. And if a system is in equilibrium, what do we know?
That the sum of clockwise moments and anti-clockwise moments are equal.
Good job, Virginia. You said it before me, but I'm so
Oh,
proud. I'm a
thank you.
proud mother. I'm a proud mother.
Thank you,
Right?
Renish.
And weight is an example of a what?
Force.
Exactly. An example of force. What's the formula for weight?
Mass times gravitational acceleration.
Right? So W is equal to mg. Cool. And what's the formula for moment?
Force times distance.
So if there's any questions that you're gonna do tonight, I wanna see if I could answer one. I just wanna feel important, you know?
Okay, no problem. That sounds so sad.
No, not in that way. I mean, like, to understand physics more.
No problem. So, guys, if any of you are confused, W stands for weight, M stands for mass. So, okay, let me explain. The mass is the amount of matter a body has. So, like Fat Man Bob Belly just fill up a chicken, right?
Not only chicken alone, fries too,
Right.
everything.
Everything. So, mass is the amount of matter you have in a body. That doesn't change. Like, generally speaking, it doesn't change. Like, if you had a metal ball, the mass for the metal ball wouldn't change, it would remain the same. And you're going to multiply that by the gravitational field strength.
Good night, good night.
Good night.
Nikolai, good night.
So you're probably wondering, but sir, what is gravitational field strength about? Well, because we're on Earth, and Earth is a body that has mass, anything that's on Earth is going to be attracted to the center of mass of Earth. So, hope you guys understand that. Like, so gravity is what pulls you to the ground. If you understand what I'm saying. If you drop something, gravity is what's gonna cause the body to accelerate downwards to the ground. So gravitational field strength could be thought of like a force that attracts you to the center of a celestial body. Hope you guys understand that. And the
Yes.
the gravitational field strength of Earth we typically just say is 9.81 ms minus 2, or we just typically say is 10 ms minus 2. And so what I'm saying is, if you drop something in Earth, it's gonna accelerate downwards due to gravity at a rate of 9.81 meters per second squared. Some people will also say 10 meters per second squared. So if you're in a planet that has a weaker gravitational field strength, then the acceleration will be less. So Virginia, if you go on the moon, right, where the gravity is less, if I drop you, will you fall as fast as on Earth?
No, sir.
No. Right, so the gravitational field strength on the moon would actually be weaker. So if I drop you, the rate at which you fall, aka the acceleration, would be weaker.
Oh, okay.
Right? So do you understand that?
Yes, sir, I understand that.
So once you guys understand these concepts, we could actually do a question. So let's do a question. Are you ready?
I don't know. I hope so.
Nah, it gonna be easy. So
Okay.
guys, if you need
So
to,
I willing to try, but I'll
no
take a
problem.
screenshot for safety measures.
Alright, so no problem. So guys, I'll add on the sound of moments. Oh, and one more thing. I want you all to finish the sentence for me. If force increases, what happens to the moment? The moment what?
No, the moment decreases
Nah, it would increase.
Also
or
increases.
increase. Oh, okay. Hold on. Sorry. I just wanted to try a thing.
No problem. So for those of you guys that are confused, here is a scenario where it would make sense for you. So look at this example over here. So it's RT. So RT. Can you see that Virginia and Fat Man Bob are the same distance from the pivot? Can you see that Fat Man Bob and Virginia are the same
Yes,
distance from
sir.
the pivot?
Yes, sir. I'm seeing that.
But
For Virginia.
exactly. So RT, which body do you think will create a greater moment? Do you think Fat Man Bob is gonna overpower Virginia, or Virginia is gonna overpower Fat Man Bob? What do you think?
Fat Man Bob. He's the biggest one.
Exactly. So
I
what I'm
mean to be
saying,
fatphobic.
so what I'm trying to say is, okay, so people don't understand this, right? But weight is actually a downward force. So RT, from this example, you can see the greater the weight or greater the force, then the greater the moment. Remember, moment is the direction in which it turns. You can think of moment like that. So if the force is more, then the moment is going to be greater. I want you all to finish this for me as well. If the distance
That was reading myself.
Alright, well, you take a shot at this one. If the distance from the pivot increases, then the moment what?
I'm gonna see what I said the first time, hopefully correct.
Nah, it wouldn't be correct.
Increase?
Yeah. Increases.
Well, I didn't say it technically. I think it, but then I say increase. So, okay, I tried.
I have a question, guys. I have a question, right? Talk to me, guys. If I take Fat Man Bob and I bring him closer to the pivot, will his moment increases or will his moment decrease?
Decrease.
His moment would decrease.
It
You guys
decreases.
understand that?
Because he's not the end anymore. He in close to the middle of the.
Exactly. Wait, let me give you all a practical example, right? So you could actually understand what's going on. Because I feel like a lot of people confused.
Yeah, I still kind of confused. It's like it didn't stick in my head.
Alright, let me give you an example, right? So right now the Apple Pencil is just the Apple Pencil. So it's uniform. So where do you think the center of gravity would be for this?
In the middle of the Apple Pencil. The middle.
In the middle.
Excuse her after the class. I could talk to you in private, please.
No problem.
Thank you.
So guys, it's in the middle because Virginia, the weight on this end, you can think of it like this: the weight on this end and the weight on this end is like distributed evenly, so it's like it's balanced. If I add something to the Apple Pencil, do you still think the center of gravity would be in the middle?
No.
Where do you think it'd be? Do you think it'd be closer to this side or closer to the other side?
Closer to the side with the object, so right? Wait, no?
Wait, yeah.
Oh, okay. Wow.
So what I'm trying to say is, so Virginia, by me adding this mass to the Apple Pencil, for me to balance this, right, did I have to go, so okay, I want you to understand that this side of the Apple Pencil has a weight, right? It's weighing down. But by me adding this weight to the Apple Pencil, I increase the weight on this side. Do you agree?
Yes, I agree.
And if I increase the weight on this side, then I have more weight acting down over here.
Yes, sir.
Now, when I put my finger over here, my finger acts as the what? What does it act as?
The pivot or fulcrum.
Exactly. It acts as a pivot. So remember, you have a weight acting down on this side and you have a weight acting down on this side. And the weight on this side is more, right?
Yes, sir.
So for me to balance it now, I need to take my finger and put it closer to the object so I could decrease this side's what? So I could decrease the what on this side.
The moment.
Exactly. So by me taking my finger and bringing it closer to this side, I decrease the moment on this side.
Okay.
I still feel like you're confused though.
Yeah. This is like what confuses me a little bit.
We're not gonna finish till you understand it fully.
Okay.
So let me stop share and let me share your screen. Or let me share my screen.
Okay.
I don't want anybody to be confused. Alright, so Virginia. Somebody keep calling now. Alright, cool. So let me ask you a question. So Virginia,
Yeah.
I want you to okay, so talk to me, right? So Virginia, at the pivot, what is the moment? At the pivot, what is the moment?
0 in equilibrium.
Right. If I move it further away, what is the moment right now?
6 newtons.
6 Newton meters.
6 Newton meters. Sorry.
If I move it further away from the pivot, what increases?
The anti-clockwise moment
Exactly. So Virginia, the further you go from the pivot, the moment what?
increases.
No, you're seeing that for yourself, right? Like you're actually seeing it. Like watch.
Yeah.
Let me
Yeah.
use something that's more drastic so you can see it better. Where's the moment right now?
0.
Where's the moment now?
10 Newton meters.
What is it now?
20 Newton meters.
What is it now?
50 Newton meters. Whoa,
So
100.
so the further I go from the pivot, what happens?
The moment increases.
Exactly.
Okay. Okay.
Let's do it on the other side now. Okay, so Virginia, I have that right.
Yeah.
What is the clockwise moment right now?
100 Newton meters.
Right, I'm going to go a bit closer to the pivot. What is the clockwise moment now?
20 Newton meters.
So tell me, generalize that statement for me. Tell me the statement. What does that mean?
Okay. So closer to the pivot, your moment will decrease.
Yeah, you're seeing that for yourself.
And the further away you carry the object from the pivot, your moment would increase.
Exactly.
Okay. Okay.
I feel like there's something that's still confusing here.
I don't know what it is, but like I get it, but I feel like it wouldn't stick with me. I don't know.
So she remind me of me. Yeah. Yeah. I could
Excuse me,
see it
sir.
physically, but is that still it's still not kind of clicking.
Excuse
I
me,
feel
sir.
like
Wait,
Notes for
somebody's
tonight
asking
that
a
you're
question.
doing. The notes that you're doing tonight. You send anything if you send it in the group chat
Which group chat you in?
in the behave driven.
Okay, I will send it in the group chat then.
Thank you.
okay, I feel like I just have to like memorize it.
No, don't do that. Let me ask you a question, Virginia. If you're using a crowbar, where would you apply the force? Close to the pivot or further away from the pivot?
Further away.
If you're
Also
opening if you're opening a door, would you want the doorknob close to the hinge or far away from the hinge?
far from the hinge, else it won't open.
Exactly. If you want to use a screwdriver, would you use a short screwdriver or a long screwdriver?
A long one?
Exactly. In all instances, where do you go? To make your work easier, where do you go? Closer to the pivot or further away?
Oh, further away.
Exactly. And Virginia, that's because if you go further away from the pivot, what increases?
Your moments would increase. Okay. Okay.
Exactly.
I think I connecting the dots.
And I mean, you see that for yourself here. Like watch. Where's the moment right now?
In the middle, so it's 0.
Exactly. Mm-hmm. Where's the moment right now?
25 Newton meters.
Right. What is it now?
75 Newton meters. And it increases proportionally when you bring it further away from pivot.
Yeah. Wait. Say that again.
It would increase proportionally further away from the pivot.
Yeah. So the
Okay.
further you go, the greater the moment.
Okay.
Seeing that?
Yes, sir, I'm seeing it.
Okay. So like, I want to like give you an example, right?
Okay.
Okay, so like let's do 2 and 4. Okay, so right now my system is in what?
Equilibrium.
Right? Who's winning right now?
The anti-clockwise moments.
Okay. Let's take the anti-clockwise moment and bring it like by 1. Okay?
Okay.
if I want, so tell me, Virginia, which one weighs more, the the um the 4 kilogram block or the 2 kilogram block? Which one has a greater weight?
Definitely the 4 kilogram block.
So okay, remind me, Virginia, where does it have the greater moment? Closer to the pivot or further away from the pivot?
Further away from the pivot.
So if I want to balance the system, okay, first of all, Virginia, do you agree that both of them have different weights?
Yes, sir.
So Virginia, if I take this 2 newtons and I put it at the same distance as the blue block, will it balance?
No, I think you'd have to move it to 2 meters.
Bam.
Oh wow. Absolute cinema.
You understand it now, right?
Yes, sir, I understand now.
So the further you go from the pivot, the greater the what?
Greater moment.
Exactly. Exactly.
Okay.
And the greater the weight of the object, the greater the
Moment as well.
exactly. So Virginia, if I increase the weight to 5 and I leave it at the same spot, do you think my system will be balanced?
No, you'd have to bring it a little closer.
Well, let me see. So 5 and 2. Wait, Renisha, we'll talk to you just now. So look at that. You see, we had to bring it closer.
Oh yeah. Okay, I understand now. This
So you,
makes sense.
so you understand, Virginia, because that block was heavier, we had to decrease its moment by bringing it closer to the pivot.
Yeah, but I have like an example, and I'm just like curious about it.
You have an example that you're curious about?
Yeah, and I just want to like make sure it's true.
You want to summon the question?
Okay. No, it's like something that happens in real life.
Talk to me. Give me the example.
Okay, so basically, you know how parents go to the playground with their kids, and you know they would go closer to the seesaw, and the child would go further away. Is that to like balance the moments more or less?
Yes.
Oh, okay.
Give me one
Makes
second. I think this is what you're talking about. Right, so look at this, right?
Yeah.
So Renisha, who is weighing more
Yes,
here?
sir.
Who's weighing more
The
here?
parents. The
The
parent.
parent, right?
Yes.
Right now, both of them are the same distance from the pivot. They're the same distance from the pivot. Same distance.
Yes, sir.
So people on TikTok, I'm not seeing anybody commenting, but right now, guys, this is the pivot here, right? This little dot here where I'm pointing to. Or y'all can't see that dot. Are y'all seeing me fulcrum, people on TikTok? Because I feel like a lot of people
Yeah.
are
You
confused.
see it. You see it clearly on TikTok.
Can y'all see like the yellow dashed and like the little blue circle there? That is the fulcrum on the pivot, right? Talk to me. So Renisha,
Yes, sir.
the
Yes,
mother
sir.
the mother distance from the pivot and the daughter's distance from the pivot, are they the same or are they different?
Different.
No, they're the same.
Oh, sorry. My glasses. I need to wipe off my glasses. Alright. Mommy, shh. Oh gosh. You're embarrassed with so mommy.
Check that out. Can you see that the distances are the same? Watch, look at
Yes,
it.
sir. It's the same. I seen it's the same.
Right, the distances are the same. Now, remind me, Renisha, the further you go from the pivot, what increases?
Moment.
Exactly. So, Renisha, which moment is winning? The mother's moment or the Sarah's moment?
The mothers.
Exactly. So we have to increase Sarah's moment. So to increase Sarah's moment, are we gonna move her closer to the pivot or are we gonna move her further away from the pivot?
Further away.
Let me see. Look at that.
Oh wow, I was correct with something. Yay!
Right?
Mommy,
So you see, guys, the further you go from the pivot, the greater the moment is going to be. So Virginia, this literally answers the question because it's a mother and a daughter.
Yes, sir. I was shocked when you had the exact model. Whoa.
Yeah. And so like Let me run through that one more time. Right? One more time. So, guys, right now, so people on TikTok, which moment is winning right now? The mother's moment or the daughter's moment? People on TikTok, let me know. Whose turn and effect is winning? Which turn and effect is winning? The mother's moment, right? Now, remember, if you want to increase the moment or the turning effect, you go further away from the pivot. So, if I send the child further away from the pivot, her moment is going to increase and it's going to be the same as the mother one, even though they weigh two different, even though they have two different masses and as a consequence, two different weights. Are you understand that?
Yes, sir.
Now, if I take Sarah and I move her even further away from the pivot, do you think the system would stay balanced, or do you think it's gonna is gonna go in her favor now?
In her favor.
People on TikTok, talk to me. So if I take Sarah, right now the system balance, right? But if I take Sarah and I push her further to the end, what would happen to the system? Do you think it would stop being balanced, or what do you think? What do you think would happen, guys? It's going to go in her favor. Let's check that out. Whoa! Yeah, so now her turn effect is greater than the mom's. Do you guys understand that?
Yes, sir. I finally understand.
Understand
Good.
it better.
Now, if I want to balance the system, what would I have to do with the mom? Would I have to take the mom and bring her closer to the pivot or further away from the pivot?
Further away, so it can be balanced.
I don't have the exact I wouldn't be able to exactly balance it. Let me use I could probably use 1 and 4, right? Alright, so right now the system is not balanced, right? I want you guys to tell me when to stop. So I'm gonna move her further away. Oh, look, it balanced.
Oh, wow.
Wow.
And the reason for this is because remember, moment is equal to force times distance. Virginia, Sarah's weight right now, do you guys remember that weight is actually a downward force? Weight is a downward force. Weight
Yes,
is
sir.
a force. So
Yes.
if we take the 1 and multiply it by her distance, which is 4, what do you get?
4 Newton meters.
Exactly. And the mother's weight is 2, and the distance is 2 here, so it's 2 by 2.
Also 4 Newton meters. I see.
Exactly. So the system therefore is balanced because the anti-clockwise moments is equal to the clockwise moments.
Oh, okay. It all makes sense now.
Yeah, sure.
No, I'm sure.
Right. People on TikTok, I see the numbers decreasing. I feel like a lot of students prefer when a teacher just tells them learn this off and just continue, but I don't do that. I want their brain to hurt. I mean, I say
Yeah.
I want their brain to hurt. I want them to use their brain and actually understand and apply yourself. Because you guys will have to deal with situations like this in real life, and you'll have to think. You'll have to use your brain. You'll have to use your brain. I don't want you guys to just.
Yeah, that's what I appreciate about math vibes.
Thank you, thank you.
No
So here
problem.
what? I'm going to increase the mother's weight to 4. Okay, so guys, talk to me, right? I increased the mother's weight to 4 now. Which moment is winning?
The mom.
The mom's moment is winning, right? So,
Yeah.
for me to give Sarah a fighting chance, what would I have to do?
Increase the distance to 8 meters.
Now, that wouldn't be possible in this particular swing.
Oh,
So, the solution is quite simple. But you're not going to figure it out. So, guys, talk to me, right? So guys, Sarah's weight, right now it can't change, right?
yeah.
Now we move her as far away as we can from the pivot. There's no more room to move her further away. But if there was room, we could just keep pushing her, right?
Yes, sir.
So here what we're gonna do, here's the solution.
Bring her closer.
No? I mean we could, right? We could bring her closer. Let's see. What are you doing, boy? Yeah, yeah. So you could bring the mom closer. You could bring the mom closer. So you guys were correct. Yeah, you could do that. Or I like what I'm about to do a bit more. We're gonna feed her some KFC.
Oh, I
We're
see.
gonna feed her some Kentucky Fried Chicken, guys. And if
Yes.
we do that, what's gonna increase? Her what?
Oh, wait. So the force.
Yeah. Bam. Look at that. Yeah.
Absolute.
Yeah. So we give her some fried chicken and she weighs increase.
Ah, I see. I see.
But I feel like you all have a good idea of the concept.
Yes, sir, I do now. This is what I was lost about, like, forever. And I would understand periodically and then forget.
So let we like lock it in stone.
Okay.
It's a shame like people leave. Like people like leave before they understand. It's like people don't like to be uncomfortable. They don't like to use their brain. Like
Oh,
they like people like solutions, but you had to think. You had to think. I I feel like the way in which I teach physics will make a lot of people uncomfortable because I make you use your brain. You had to use
oh,
either way to memorize anything. You had to use your brain and figure it out.
okay. But let me rejoin the Zoom real quick. I'm not seeing the screen. It's my internet.
You not seeing your screen?
Yeah, it's not you. It's my laptop.
Okay, no problem. So join back. So Renisha, wait to redeem yourself, right?
Yes, sir.
Renisha, see moms and things. She looking. She learning some physics too, boy. Moms, you learning some physics?
Yes, sir.
Like it making sense?
Well, yeah, now learning it. I never did physics in my life, so.
That is no problem. That is no problem. So I'm gonna ask Renisha's mom this. So Renisha, mom. So like if the so like you see in the force, right? But like weight is actually our force. So like talk to me, Renisha's mom. If a fat person sit down and never gonna happen.
What's the answer? That's a serious question, mommy.
That's a serious
Still,
question. If a fat person sit down and never gonna happen.
you get squeezed.
Yeah,
Exactly.
get flat only.
So the fat person has a lot of mass. So because of gravity is gonna generate is gonna give a weight, right? And because the person is fat, the weight is gonna be a lot, and the weight is where you actually feel pressing against you. So long story short, weight is just a downward force. It's just a downward force. If you sit down on somebody, you're gonna apply a downward force because of gravity and mass. You understand that?
Yes, sir.
So when you see force, I want you to just think weight, right?
Yes, sir.
Just think weight.
Thanks for that, sir.
No problem.
Appreciate it.
So if the weight increases, what would happen to the moment? You think it would increase or decrease?
Repeat, sir, what you said?
So if the weight of somebody increases, so like here what? Imagine you're on a seesaw, right? Imagine you're on a seesaw, and you have a fat person on one side. What happen to you?
Well, the fat person will go down and go be more up in the sky. And more up in the
Exactly.
air.
Exactly. So in that instance, I would say the fat person has a greater moment. Moment is just a fancy word for turning, like the direction it's turning. That's all. So talk to
Okay.
me. If the weight increases, then the moment would what? Will it increase or will it decrease?
Decrease.
Nah, think about the fat person. The fat person has a really, really great weight. And so
Because the fat person going down, so the fat
exactly.
person decreasing, and the smaller person will increase.
Well, I don't want to think about it like that. The the fat person would overpower you. So their
Yeah.
moment would actually raise, would actually increase. So if weight increases, the moment actually increases. And again, think about it. If a fat person goes on the other side of the seesaw, wouldn't they overpower you?
Yeah.
Yeah. So the reason for that is because persons with more weight would increase the moment would increase. Yeah. Now, if the distance, so Renisha, you answer this. So Renisha, if
Yes,
the
sir.
further away from the pivot, what would happen? The moment would what? Increase or decrease?
Increase?
Yeah, it would increase. Remember, Renisha, it had some points in time where we had to take the daughter and move her further away from the pivot for it to be balanced. Remember that?
Yes. For it to be balanced, yes, sir.
Right. And when we did that, we were actually increasing the moment of the daughter.
Yes, we were.
But if I take the daughter, Kimaya, if I take the daughter and I bring her closer to the pivot, will her moment increase or decrease?
It would decrease.
Exactly, it would decrease. Virginia. So, Virginia, I have some questions for you.
Okay.
So, again, just intuition.
All right.
Talk to me, Virginia. Do you think the system is balanced right now?
No.
No. If you wanted to balance, so like Virginia, we already maxed out this object's moment, right? We've maxed out this object's moment because why Virginia? Like why?
Because the further distance you are, the greater moment you have.
Can we go any further?
No, sir, we can't.
You can't. Now you can't do anything with this one, that object. So, but what other object you could change?
The one on the left side. So perhaps we could
Exactly.
move it closer.
Exactly. So Renisha, this system is not balanced. But for it to be balanced, Renisha, do you think we should move the bigger object further away or closer to the pivot?
Further? No, wait. To be balanced, it would have to be closer to the pivot.
Closer, yes.
Because
reason-
the smaller one done far away. If you
Yes.
push the bigger one far away, it will be unbalanced.
Yes. Hey, big up, Renisha. She gets it. She gets it.
Thank you. I feel like I'm right up. Thank you. That's what to do today.
So, does everybody on the TikTok, everybody on YouTube finally understand that the further you go from the pivot, the greater the moment. But if you go closer, you're decreasing your moment. Now, Virginia, this object weighs a lot more. It weighs a lot more, right?
Yeah.
So, do you think we want it far away from the pivot or close to the pivot?
Closer. Because if we put it further, it would like be greater than the other one. And there's no changing.
Exactly. That's it.
Okay. Okay, I'm getting this.
Yeah, yes, you are. So I think you're all ready for a question now. I think you're ready for a question.
I hope so.
You could. Oh, I was gonna ask if you could have back up. Let me see
Yes,
this part
sir.
here.
I'll let you take a screenshot of this. But before I do that, right, I have a simple question to ask. We need to be able to analyze clockwise and anti-clockwise movements. So this object over here, I want you all to forget about this for now, right? If you apply a force on that side, Renisha, wouldn't this side of the seesaw go down and this side go up?
Yes.
What direction is that? Clockwise or anti-clockwise?
Anti-clockwise.
Right. So this object is generating an anti-clockwise moment. Now, guys, if we apply a force on this side, then the seesaw would dip down and it would rise on the other side. All you understand that?
Yes,
Yes,
sir.
sir.
So, like, if I were to connect it, what direction does that look like? Clockwise or anti-clockwise?
Clockwise.
Clockwise.
So that's going in this direction. Now, we understand that the formula for moment is equal to what by what?
Force by distance.
Force by distance.
And if force increases, what increases? Fast.
The moment.
Right. If the distance increases, what increases?
The moment as well.
Exactly. Right? So cool. And this system is balanced, so we would say anti-clockwise is equal to clockwise.
Yes, sir.
Okay.
Because the
So,
anti-clockwise and the clockwise has to cancel off for it to be balanced. Yeah, we need to
Yes.
talk to me.
so I could just get a screenshot of the little note on top
Yeah,
for
yeah, no
me, please.
problem.
Thank you.
So here what? We could do two questions and we could take a little break and then we go move on to maths.
Okay.
Yeah, my favorite.
I feel like
What?
I feel like people just do like physics because of how much thinking you have to do. I feel so.
Oh.
Yeah, boy. All right. Okay. All right. Let's do a question now.
Okay.
So again, remind me, for a system to be balanced, what is the number one number one concern?
Um, the force and distance,
Nah.
clockwise and anti-clockwise movements.
Yeah.
Pivot.
Yeah, they
And
have to be equal.
okay. Okay.
Renisha, mom, I have a question for you. Talk to me, right?
Yes. Yes.
If you want something to be balanced, then you want the moments to like cancel off, right?
Yes, sir.
So one of them going in a clockwise direction and the other one going in an anti-clockwise direction. If they are the same, what do you think they go do with each other?
Uh, I would try to get. I would try to differentiate the bigger one from the smaller one.
No, but hear what I'm saying, right? Both
Uh,
of them are the same. So like the clockwise and the anti-clockwise are the same. So what would they do to each other? Let me give you an example,
Fine.
right? So imagine you're pushing with a force of 5 newtons in this direction, and you're pushing with a force of 5 newtons in the other direction. What happened there? What do you think?
It will collide.
It will collide and it will do what? Both of them is the same, but like it going in opposite direction. What happened?
Well, if two things meet up, it will cause accident, so it will collide and mash up.
Yeah, and they will cancel off.
Yeah.
Because this one is 5 and this one is 5. Both of them is the same, but they're going in the opposite direction. So they just cancel off. Okay, so like the point I'm trying to make is if it's the same but opposite, it will cancel off. Like, okay, let me ask you a question. If you take hot water and you mix it with cold water, what will happen?
It will get lukewarm.
Exactly. You can think of lukewarm as it canceling off. You understand?
Okay. Yeah.
So like
Yeah.
if I have a clockwise and I have an anti-clockwise and they collide, it'll cancel off.
Okay. Cancel.
It will cancel off completely.
I think that's it.
So it come like you're adding equal parts hot water and equal parts cold water. Do you understand that cold water and hot water are opposite, right?
Yeah.
But when you mix them together, they will cancel off. And to get lukewarm water. Yeah. Or like room temperature water. So it's the same concept over here. So guys, Kimaya, do you understand that this and this had to be the same for it to cancel off?
Yeah, I think I have a understanding.
Alright. So Kimaya, let me make sure you understand it.
Oh my god.
We don't work with I think I understand here. So like
So I was kind of taking my little notes in between
mm-hmm.
while I was talking. So what I understand is the further I is from the pivot, the moment will increase, and the closer I is from the pivot, the moment will decrease.
Yeah, that's true. Now I have a question for you. If I push on this side of the Apple Pencil, wouldn't this side go down and the other side increase?
Yes, it will.
And if I push on the other side, wouldn't this side go down and the other side increase?
Yes, it will.
So like this side wants to go down here, and this side also wants to go down, but because the moments are the same, they just end up what? Wait, sorry.
At the equilibrium.
Give me 1 second. Give me 1 second. So at this instance, both moments are doing what to each other. Remember, this side wants to go here, and this side wants to go here. But because it's balanced, both of them doing what to each other.
The canceling out each other.
Yeah, they're canceling out each other. And so what I'm saying is the anti-clockwise moment, which is in one direction, and the clockwise, which is in the other direction, they had to be the same so they could cancel out.
Right.
You understand?
Yes, I understand.
People just want the maths, you know. But it's more people that when we were doing hard maths, for sure.
Yeah, for sure.
Okay, so cool. Let's do a question. We need to do a question.
Okay.
Let's apply our knowledge. Right? So, Virginia, let's run through this.
Okay.
Wait, people on TikTok are real quiet, boy. Are you all understanding anything? Alright, so who wants to do this question with me? Renisha, Kamaya, Virginia, Neela.
Sure.
I see Kamaya on mute.
Oh, sorry.
Alright, so Kamaya, give it.
I will
away
try
to
the
her.
other question.
So I
problem.
feel the first one might be, I don't know, I just assuming. I think it might be equilibrium. Because equilibrium means like to even out.
The balance, yeah. But like, tell me, people on TikTok, on YouTube, and on Zoom, does that look balanced to you all?
Let's see.
No. Which moment is winning? Keon's moment or Raj's moment?
Raj.
Raj.
Raj's moment, right?
Yes, sir.
All right. So if I want Keon to cancel off with Raj, I had to move Keon closer to the pivot or further away from the pivot.
Further away from us.
Until you remember that, the further you go from the pivot, the greater your moment. So remember that.
Yes, sir.
So if I want this to balance, I need to take Keon and I need to shift him further from the pivot.
Okay, I see.
You sure you see that, Virginia?
Yeah, I'm 100% sure.
Right? So, Kimaya, read that for me.
In the figure below, Raj and Keon are sitting on opposite ends of a seesaw. They are currently balanced each other. Two distances are labeled.
Alright, to achieve what? The what moment created by Keon must be equal to the what moment created by Raj.
I was saying equilibrium.
Yes. That is what you should say. Right? That's what you should say. So to achieve equilibrium. Now, do you understand that equilibrium is just another way of saying that the system is balanced?
Yeah, like even, saying even.
Because it kind of sounds like equal, right? Equal. And we just discussed that, the clockwise and anti-clockwise, if they're equal, but they would cancel off because they're going in the opposite directions. Right? So to achieve equilibrium, the what moment created by Keon, here what? We need to figure out what they're talking about. So, wait,
So
come on.
that's clockwise and the anti-clockwise thing?
Yes. So we had to figure out what type of moment Keon creates.
Keon created like an anti-clockwise.
You get that fast, boy.
So
Excuse
when
me.
my nerves thinking up, my brain just start to click. Like my nerves just acting up right now.
Okay. So, let me explain to anybody that might be confused. Let's remove Raj from the equation, right? So right now, you just have a force acting on this side, right? That side. Okay? If you apply a force on this side, wouldn't this side go down and this side go up?
Yes.
Yes.
What kind of moment is that?
Anti-clockwise.
Anti-clockwise.
While
Yeah, that is anti-clockwise. So Keon is going to generate an anti-clockwise moment. And now let's look at, well, guys, I want you all to use intuition. If pushing on the left-hand side creates an anti-clockwise moment, then pushing downwards on the other side will generate a what type of moment?
Clockwise.
Clockwise.
Yeah, that makes sense. That makes sense. Intuitive sense. And you can see it for yourself, right? If you push downwards here, this side is going to go down and this side is going to go up. Can you guys see that that is a clockwise direction?
Yes, sir.
Yes, sir.
Okay, cool. So the what moment created by Keon? What type of moment is Keon creating?
anti-clockwise.
Right? So the anti-clockwise moment created by Keon must be equal to the what moment created by Raj. I think we know that is clockwise. Right?
Clockwise.
Yeah, clockwise.
Good. Now, Kimaya, read that other part for me. By the way, Renisha, you understand so far or not?
Yes, sir. I understand so far.
Alright, so Renisha, remind
Yes.
me, which moment is stronger right now, the clockwise moment or the anti-clockwise moment?
Stronger.
Yeah.
I would say the clockwise.
Yeah, because isn't the swing tipping in Raj's favor?
Yeah, it's tipping in Roger's favor. Although he
So,
may look small, well, bigger in size to Keon, literally.
alright. So, Renisha, logically, if I wanted to balance the system, would you bring Raj closer to the pivot or further away from the pivot?
Closer.
Yes! 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 Yes. Because right now, Raj's moment is more. So if you want to decrease his moment, you bring him closer.
Yes.
Right. Right. Virginia, do you understand that?
Yes, sir.
Right? Cool. So, Kamaya, read this for me.
If Raj has a weight of 450 newtons, calculate Keon's weight if the seesaw is balanced.
Right, so Kimaya will underline this key part. The seesaw is balanced. For a seesaw to be balanced, what is the equation we could form? What is the condition? What's the condition? You know this? You know
So
this?
I think you might have add like two to like Raj, because Keon is 8, and if you like add, like you carry him back a little bit, that might even out.
Wait, no, that's not what I'm asking. That's not what I'm asking. If a system is balanced, what relationship does the clockwise and the anti-clockwise moments have? Like one is more than the other, they equal what?
So equal, they could be equal.
Right. So in physics and in maths, anytime you want to solve for a variable, you must form a system of equations. So you could solve the equation. So come on, yeah, they say it's balanced, right? If it's balanced, then the anti-clockwise moments could be equal to the what?
Clockwise moment.
You fully understand that, right?
Yeah.
And using this, we could figure out what are we trying to find for in this question?
Trying to let them be even.
No, read back the question again for me.
If Raj has a weight of 450 newtons, calculate Keon's weight if the seesaw is balanced. So that had to be the same weight.
No, read it back again. What a way to calculate.
Keon's weight if the seesaw is balanced.
So what do they want us to calculate?
Keon's weight.
So what do we have to find?
Keon's weight.
Exactly. If I tell you how to calculate something, okay. If you knew something in the first place, Kamaya, would you have to calculate it if you knew something?
No, because the answer already there.
Exactly. Why would you calculate it? But in this question, they're saying to calculate Keon's weight. So what we had to find?
Keon weight.
Exactly. Now, Raj is 450 newtons. Let me ask that question. Are both of them the same distance from the pivot?
No, they are not.
They are not. Let me make a better scenario. Now, we know in that question there that the system is actually balanced, right? The system is actually balanced. So tell me, Kamaya, what is the distance from Keon to the pivot?
0.6 meters.
0.6 meters. What is the distance from the pivot to Raj?
0.8 meters.
Say with me there, right?
Yes.
Okay, and in the question, they just told us the weight of who? Whose weight did they tell us?
Raj,
Raj. So by Raj, I'm gonna draw a upward arrow or a downward arrow. What kind of force is weight? Weight is a what kind of force? Upward force or downward force?
downward force.
That makes sense, right? Weight is clearly a downward force. This is a downward force. So by Raj, I'm just put K for Keon and R for Raj here. Yeah, so by Raj, I'm gonna put 450 newtons. Okay, does everybody understand how I did that diagram?
Yes, sir.
Yes, sir.
So the distance is away from the pivot and the
Yes,
weight.
the distance is always from the pivot. Always. 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 You will have to understand that. Always from the pivot. Yeah, I'll understand that, right? It always from the pivot. Yeah?
Yes, sir. Yes, sir.
Yeah.
Okay. Cool. Let's begin solving. So Kimaya, you could do this. This is easy. So Kimaya, whose moment could I calculate immediately?
Raj one already done. Okay.
Well, we know what. Okay, remind me. What's the formula for moment?
Moment is force times distance. Wait, wait. So I just asked 2 minutes. I'm not too sure. So if
Possible.
to find moment is force times distance. The force on Raj is 450 newtons and the distance is 0.8 meters. So if the distance is like 450 for the k, you're gonna have to multiply that by 0.6.
You get in there. Yes, yes, yes. You get in there. So you did really well with this, right? So like, let me understand something. I just want to reiterate something. So far, Kimaya, do we know the weight of Keon? Do we know the weight of Keon?
No, we don't know the weight of Keon yet.
Yet. So here what? If you don't know something, you'll call it W. Like, we don't know what that is, right? So we'll call it W for now, yeah?
Yeah.
But do we know the distance from the pivot?
Yes, we do.
Alright, by the way, big up New Yorker chicken in the chat. You all could sponsor me, guys, for you want, and I could advertise your chicken.
A sponsor, sir. So we can have a class party.
Yeah, yeah. All you have to understand, I like fried chicken, you know. I love. You asked me the other day, what is my favorite food? Vegetarian food, and I had to look at you like vegetarian food. What do you mean favorite vegetarian?
Yes, mommy.
Did I have any favorite vegetarian food?
Nah.
I don't
Nah.
The only thing I could think about is a salad from Subway and them let's do sandwiches.
You mean to tell me? Ask somebody favorite vegetarian food? What?
Nah, nah.
Be shaken. But
I feel
anyways,
safe.
so guys, do like Kimaya, you're going real good, right? Just to remind me, Raj is a what kind of moment,
clockwise moment,
and Keon is a what kind of moment,
anti-clockwise moment.
and for it to be balanced, both of them had to be
Well,
equal.
equilibrium.
So let me begin. Let's calculate the anti-clockwise moment. We know anti-clockwise moment is force by distance.
Right.
Do we know what the force or the weight is for Keon?
No, we don't.
No. So I leave that as W and I multiply that by the distance from the pivot. What is Keon's distance from the pivot?
0.6 meters.
Right? Let's look at the clockwise moment now. Who is creating the clockwise moment?
Raj,
Raj. What is Raj's force?
250 newtons.
What is his distance?
0.8 meters.
So we have W by 0.6, which is just 0.6 W. And we have 450 by 0.8. What is 450 by 0.8?
That is 270.
Yeah, sure.
Wait, 450 by 0.8?
Use a calculator. Don't use it. That's 360.
Yeah, 360. I
So
was
what about?
multiplying 0.6 by 450.
So,
I see
so
Renisha has a hand raised. Talk to me, Renisha.
was now when I say what happened there? I use my brain mentally and work out that, and I get 360.
That's good.
I thought I had wrong. Thought I had it wrong. I
Nah,
really
that's
thought.
correct. So now we have to do some algebra. So Kimaya, over here we have 0.6 times W. What we want to find for W. So what would I have to do to cancel off the 0.6?
Divided by itself?
Yeah, so I have to divide by what?
0.
And if I do that on one side, well, I have to do it on the what?
Yes, you have to do it on the other side.
Because it's an equation, equality.
Exactly.
That's a sensitive matter in 2026 though, equality.
What?
I kind of want to talk about that. So what is 360 divided by 0.6?
600.
Where you get?
600.
I can't hear.
Yeah. I get 600.
Let me verify that.
Oh,
Yeah,
wait.
that's it.
Yeah, 600, 600.
And the unit, okay, weight is an example of a force. So all forces have unit Newton. So this is 600 newtons. That's it. So the weight of Keon is actually 600 newtons. And this is the part where I blow your mind, Kamaya.
Big boy. Down.
Kamaya, what is 600 by 0.6?
260.
What is 0.8 by 450?
360. Damn.
You notice that the anti-clockwise is equal to the
Clockwise.
right.
Us,
So,
sir.
so it balanced. It balanced.
Magic. That's wow. Hey, if
Yeah.
I didn't like the subject,
Again, I understand it now.
again,
Nice,
it's I
nice,
really
nice.
get it. It's
People
the
don't
first
teach,
time I actually use my brain.
I feel like people don't teach this topic so bad in school, like it's ridiculous. Like, I feel like they just go straight into it, and students don't get like a intuition for it. They don't build up an intuition for it.
Yeah, that's true. That's true. That's true. Kamaya, I'm a sister from another mother. I miss you, girl.
Same. So I'm a brain
So,
take away.
so like, let me run through these steps, right? So, Kamaya, number one, they told you that the seesaw is balanced. If the seesaw is balanced, what do we know? We need to be able to form an equation. Remember, equation has an equal sign in it. So, like, what we know,
Something equal to something.
right? What equal to what? What we say the proper thing.
The clock anti-clockwise is equal to the clockwise moment.
Yes. So if they say a system is balanced or it's in equilibrium, the anti-clockwise moments is equal to the clockwise moments. That is your first step, right?
Right.
Now you go on your diagram and you label the anti-clockwise and your clockwise. So Keon is a anti-clockwise moment because Keon is gonna push the seesaw down there, and if this goes downward, this is gonna go upward. Can you all see the anti-clockwise moment?
Yes, sir.
Cool.
So, what you're trying to say is the whole thing is equal to 600 newtons.
No.
Isn't that what N stands for?
Yeah.
Well-
Newtons, but
Keon. It's Keon own. Not the
Yes,
whole thing. Sorry.
That's Keon's weight. Keon's weight
Sorry,
is
sorry.
600.
You see, I
So let
pick up
me.
my mistake.
That's good. So let me continue. So Kamaya, you understand that clockwise is equal to anti-clockwise, right? And
Yes.
Kamaya, to find for moment, moment is just simply force by distance.
What's my distance? Moment. Right.
And you have to understand, isn't weight a downward force? Isn't weight a force?
Yes, it is.
Right. So let's start off by finding the anti-clockwise moment.
Right.
Now they told us to calculate whose weight. Whose weight did they tell us to calculate?
Keon.
Keon. So we don't know what Keon's weight is. If they tell us to calculate something, you don't know what it is, right? So for Keon, I just labeled his weight what?
W.
Exactly. Remember, moment is force by distance. We don't know what his force is, so I'll label that W. What is his distance from the pivot?
0.6 meters.
Good. So on the left hand side, we have W by 0.6. On the other side, we need to calculate the clockwise moment now, right? So we're looking at Raj now. What is his force,
Its force is 450 newtons.
right? And his distance is 0.8. You multiply that, and you get 360. So now you have 0.6 W is equal to 360. But you trying to find for W. So you have 0.6 multiplied by W. So to cancel off the 0.6, you have to divide both sides by 0.6, and that leaves you with W. So W is equal to 600 newtons, and that's going to tell you the weight of who?
Keon.
Exactly, that's going to tell you the weight of Keon. Renisha, see you have your hand raised.
Okay, so correct me if I'm wrong, okay? I'm gonna tell you basically how I understand it, right? So what they're trying to say is, in order for us to find Keon's weight,
Mm-hmm.
we have to multiply Raj 450 newtons by 8 meters, right?
0.8 meters.
Yes, 0.8 meters. When we do that now, we get 360.
Mm-hmm.
Then we have to divide.
Wait, but
Before we divide,
Renisha. That 360 stands for what? That stands for the. That's what does that stand for? The anti-clockwise moment or the clockwise moment?
anti-clockwise. Clockwise.
Clockwise, because what? 0.8 by 450,
Okay, that's 360.
right? So the clockwise moment is 360. Now we have to go and find the other moment. So in the question, they told us to calculate the weight of who, Renisha?
Keon.
Right. So do we know Keon's force?
No, we don't.
Remember, Renisha, force and weight is the same thing, right?
Oh, right.
Weight is our example of force.
Right.
So do we know Keon's force?
No, we don't.
Right,
That's
so
W.
I'll label that W, but do I know his distance from the pivot?
Yes, 0.6 meters.
Right, so then remember force by distance, so his force we don't know what it is, so call it W. I multiply by 0.6. So W by 0.6, that's 0.6 W.
And then you
So
divide
because
360 by 0.6 and you get 600.
and
Oh,
who weight that is? Whose weight is that?
Keon.
Like here, yeah.
Newtons. 600 newtons.
And
Okay,
again,
okay.
look at this. If you multiply 0.6 by 600, what do you get?
450. Wait. So I want to redeem myself. Wait, hold on. I want to make sure it's the correct thing. I see
Use a calculator.
600.
Use a calculator.
600 by 0.6.
Use a calculator.
Oh, 360.
Right?
Sorry.
360. So that is 360. And I want you to multiply 0.8 by 450 for more.
Same 360.
Exactly. So you see that the anti-clockwise moment and the clockwise moment are the same. So the system is balanced.
So I'm so sorry.
That's okay. So let me give you guys a question to do now.
Okay. I will try my best.
So first thing I'm gonna say, this system is in equilibrium. So people on TikTok, I would like you all to try this as well. I don't formally teach SAT, but if you all want lives for SAT maths, I could do that. SAT maths is easy. When I wrote SAT maths without preparing, I think I got the high. I think I got the full score in maths, and I did kind of bad in English, and I didn't bother to write it back.
So that is good on your part. Is a math teacher, so of course you must pass maths.
Yeah. How long do you live stream for? Well, some might say 24 hours. If you know, you know. If you know, you know. Right, Nostal? Sometimes I go live for 24 hours straight. But anyways, this system is in right, so this system is in equilibrium, right? This system is in equilibrium. Cool, let me give you the system we're talking about. So you don't know the dog Fat Man Bob, or you don't know the dog Fat Man Bob.
Fat man Bob don't get fed up by eating.
Nah, he don't get fed up by eating.
Wait.
Now question, if I have a much lighter person, like say Rajiv. Now guys, intuitive, let me see if I remember it, right? Guys, if I want the seesaw to balance, will I take Rajiv and move him closer to the pivot, or as far away as I could?
As far away as you could. Because Fat Man Bob is already closer to the pivot. So you need Rajiv to be far away from the pivot in order for it to be balanced.
Because Fat Man Bob, what? He has a much greater what?
Force? Wait.
Yeah. His weight is a lot more, so his force is a lot more. Alright?
I said the correct thing? Okay.
So let's just say that Rajiv is 1 meter from the pivot and has a weight. So this is Rajiv and this is Fat Man Bob. Now Fat Man Bob advertising for KFC. Now the question I have for you guys is, and I'm going to give you Fat Man Bob's weight. How much is 5 kgs? Wait, let me just check something. Yeah, let me just say he weighing 5 kg, right? Well, that's a bad statement to make. Let's just say he has a mass of 500 kgs. Right, so let's just say this is 5,000 newtons. No, that don't make sense. That don't make sense. If I say that, then I'll be saying he has a guys, Virginia. If I said he has a mass of 500 kilograms, that would mean that he has a mass of 1,102 pounds, which don't make any sense.
Oh.
Oh wow. He's so
heavy.
huge.
He can't be that heavy, guys.
Nah, he can't be so heavy. He will fling Rajiv off at the swing.
How much pounds are they feel he weighing?
2 pounds. 2 pounds, 3 pounds.
What?
300 pounds.
I would say like
300 pounds? Okay. Well, that'll be 140 kilograms.
Okay.
So let's just say he is 140 kilograms. And let's just say Rajiv is weighing. How much do I weigh, boy? I weigh 140 pounds. So that's like 63 kilograms.
I didn't know you were so light too.
I realize. Real bright too.
Ah, see what you did there. Clock it. All right, all right, all right. I done play the fool now.
So the question for you all is, how far is Bob from the pivot? Now, just in case you guys forgot, kg tells us the what? What does kg tell us?
The mass.
The mass, right? Kg is like a measure of mass, right? It's kilograms. But moment formula works with what?
Force, for example, weight.
Force,
Force.
Yeah.
which
So
is weight.
can you guys remind me how you would calculate weight?
Force times
Mass,
gravitational. Oh, sorry.
yes.
Continue.
Mass times gravitational. I forget the rest of the word, but
Feels right. Gravity, right? Mass
yeah.
times gravity. Mass times gravity. Cool. And I'm going to tell you that the gravity on Earth is 10 ms minus 2. So guys, people on TikTok, people on YouTube, I want you all to give this question a go for me. And by the way, remember, this is the pivot, right? This is the pivot / fulcrum.
So you say we had to find how far Bob is from the pivot.
Yeah.
Okay, I'm just making sure.
Yeah, somebody said acceleration due to gravity. Yes, that's correct. Guys, all I want to see how much messages that I respond to.
Sure.
This is just like a half, because I replied to a half already.
From results yesterday.
Oh, that's scary. Oh my god.
That's scary. Can I say something, sir?
It's still going.
Nothing controversial. I just want to say something.
Yeah.
Congrats to everybody who passed all the subjects. I'm proud of you all. And for the ones who didn't, it's not the end of the world, okay? We got this.
isn't.
It
It
have
isn't.
next year.
Oh, my head is not bad, boy. Phew.
Another thing too, a piece of paper doesn't define you.
It doesn't.
Well, so would you be signing off soon? Because you're not feeling well.
Yeah, I might go for like an hour again.
Okay.
So guys, figure this question out, guys. All I could do it. Kimaya, you could do it. I know all I could do this question, man. I know all I could do this. It's not hard. This is not hard. You all could do it. So Virginia, we hit the 16.7 again, or we reach back?
We did? 6-7, sorry.
Hey, and you know what something I do?
What?
For the 24-hour marathon,
Mm-hmm.
26 to the 27.
Ah, I see. So you're back.
Oh,
I see what you did.
Yeah.
6,
I'm a
7.
smart
I didn't catch
guy.
that. Yeah, guys, I didn't catch that too, sir. I really
Yeah.
didn't catch that.
Yeah, boy.
And sir teaching us to be smart like him. Or
So-
unleashing our very best potential.
Yes.
That's my pleasure. I'm here to bring out the best version of you guys. So I'm giving y'all 2 minutes. I want y'all to find how far is Bob from the pivot. Answer that question for me. 2 minutes.
Okay, I'm done.
You done?
Yeah.
All right. Well, good. Rachel, yes, you are correct. So question, guys. Do you think Bob's distance from the pivot would be more than Rajiv's distance or less?
That's less.
Yeah,
Less?
For sure. Hey, look, Kelani, big up yourself, Kelani.
Sir,
Yeah?
I finish.
Alright. Renisha, what you get for your answer?
22.
Nah.
No. Dang it. All right.
It's not Renisha say that, her voice was like, dang it. Alright, Renisha, let me lock in and answer the question.
Okay.
So Renisha, remind me, what's the
Yes, please.
formula for moment again?
Moment.
Yeah.
Force times distance.
And that
Oh,
dis- that and
I
that
used the
distance and that
I used
distance
the
is
wrong
always from the
formula.
what? And that distance is always from the what?
Pivot?
It's always from the pivot. Now,
Use the
here's the
wrong
first
formula.
here's the first thing I'm going to do. They give us the mass of Bob and Rajiv. They gave us the mass of Bob and Rajiv. Somebody said, Richard, yes, the perpendicular distance from the pivot. So it's force times the perpendicular distance from the pivot. Right? Now, they gave us the mass of Bob and the mass of Rajiv. But to use the formula for moment, it's force by distance. So we first have to find the equivalent force for the given mass. So Renisha, what formula would I use to find weight given mass?
Weight given mass.
Yeah, remember, what's the formula for that? Weight is equal to what?
Mass times gravity.
Right. And weight is an example of a force.
Yes.
Cool.
I
So
did
what?
that formula, but I think I probably did the wrong thing. I don't know. I mean,
Right. So
you
let
know
me
what?
continue.
I'll
Let me
explain
continue.
myself after.
Right. So let me continue. So what is the gravity? Okay. What is the acceleration due to gravity I gave in this question? What's the gravity in this question?
10
And
10.
ms
ms
negative square.
And what that means
negative
is that
2.
means 10 meters per second squared. That's what it means. 10 meters per second squared.
Okay.
So if I wanted to calculate weight, which is the downward force as a result of mass, it's going to be the mass. So what's the mass of Fatman Bob, guys? What is the mass of Fatman Bob?
140 kg.
140 kg.
And what is the acceleration due to gravity?
10 meters per second square.
Yeah.
Right? So Renisha, what is 140 by 10?
1400. Well,
Newtons?
newtons. That's how far I reached, and then from there I went off the grid.
Alright.
Oh,
So I'm going to
roughly.
put 1400 newtons here. And so Renisha, what else do we need to calculate?
We need to calculate how far it is from the pivot.
But before we do that, we need to find something else.
We need to find Rajiv. What I'm looking for it right there.
It's literally right there, I promise. Literally right there.
We need to find how far Rajiv is from the pivot.
Nah, that is given to us.
Oh,
Renisha, what is Rajiv's distance from the pivot?
1 meter.
Right, that's given to us.
It's right there. I know it's right there. I can taste it in my tongue. It's right
So
there.
so we found it for Fat Man Bob. We found okay, so Renisha, what did we find for Fat
Oh,
Man Bob?
wait. Oh,
Yes.
wait. Hold on.
Wait, yes. How would I find
Yeah.
Rajiv's weight?
Okay, so how would we find Rajiv's weight?
Mm-hmm.
Mass times gravity.
Right? What is Rajiv's mass?
His mass is 63 kg.
Right? And what is the acceleration due to gravity?
The number on top by the drawing of him, right? That's what you're talking about?
Nah, talking about the acceleration due to gravity. You're talking about G.
Oh, right. 10
10 was 10, right?
meters per second
10 meters
squared.
per second squared, right? So what is 63 by 10?
63 by 10, that is 6. Wait. Hold on. I want to make sure it's the correct thing I see.
Take your time.
Yeah. 630.
Right, that is 630.
630
630 what?
newtons.
Newtons, yes. So, guys, before you do any question, any moments question, if they give you mass, you have to find what?
Wait.
Exactly. So, like in any moments question, if they give you mass, you have to find what, Renisha?
You have to find the mass times the gravity,
Which is the,
which is the weight.
yeah, that's the weight. So, in any question, you need to find the weight. And to find that, you multiply the mass times the acceleration due to gravity. Right?
Yes.
And the
Yes,
reason
you
for
do.
doing this is because the formula for moment is what? What's the formula for moment?
Force times distance.
Right. Now, as you would see here, when you're using the moment formula, you need to figure out the force. You need the force. Renisha, is mass force?
If mass is a force,
Yeah.
I would believe so.
Nah, mass is the amount of matter in our body. Weight is our force.
Okay. Okay. I'm sorry. My bad.
That's okay. Would you say weight is our upward force or a downward force?
A downward.
Alright, so weight is an example
Weight
of a
is
downward
something that is
force.
carrying you down, literally. It's pulling
Well,
you down.
well, gravity is what causes you to accelerate downwards. Um,
Yes.
the weight is just simply the product of the mass times the gravity. But yeah, weight is a downward force. So
Yeah. Weight
Renisha,
is a downward. Yes, sir.
in the question, they gave us mass. They gave us mass, but Renisha, is mass a force?
No, it's not.
No, it's not a force.
Be careful what I say this time, man. Be careful.
Right, be careful. And mass is not a force. So you first have to convert mass to,
Mass to
so remember Renisha, to use the moment formula. It's remind me, what's the moment formula?
oh, you have to you have to change mass to
You could
right
do
there,
it.
sir. It's right there, right there. You have to change mass to um
Okay, so remind me, when you're finding the moment, you
it's
multiply
force
what?
times distance, right?
Right. So you need a force. So you had to convert
Oh,
mass to,
a force.
which we call,
Wait.
yes, yes,
Yeah, I get it, I get it, I get it.
right?
It takes
So yeah,
one step at a time. And one game is
right. So Renisha, before you could use the moment formula, you first had to convert the mass to,
wait.
right. W's in the chat for Renisha, guys. W's in the chat for Renisha. She gets it. She gets it. So Renisha, let me run that back again. Kimaya, Renisha, guys,
Yes,
if you're
sir.
doing any moments question, remember to find moment, it is force by distance. You need to convert the mass to weight because weight is a force generated by an object having a mass and in a planet with gravity. Right, so
Uh,
Renisha,
I didn't mean
any
to be off topic, but my heart feeling like it palpitating over my chest. But
you'll
yes,
get it.
continue.
You'll get it. So Renisha, any question
Yes,
you have
sir.
to convert master,
Wait.
right? Because in the moment formula, it says it is
A downward force.
no. Tell me, the moment formula is what? What's the moment formula?
Oh, force times distance.
Good, good. You understand?
Yes, I do. Yes, I do.
Good. So let me soak the scene, guys.
Is that the whole question, or is there
No, no,
more to
that's not a
answer?
good question.
Oh, I was just making sure. I just making sure. Because I
What did
know you can't just leave that just so. You had to do something else in order for you to get the total answer.
Yaharel supporters on TikTok? People saying Renisha cooking. WW Renisha.
Thank
WW.
you. Love you all. Mwah.
Right? So Renisha. So
Yes,
Renisha,
sir.
talk to me, right?
Yes, sir.
So Now that we know the forces, remind me, what is Fat Man Bob's force?
His force is 1400 meters.
What is Regine's force?
613 meters.
Right? So now we need to take moments. So, question Renisha. If you're
Yes.
on this side of the seesaw and you apply a force, wouldn't this side go down and this side go up?
Yes, it would. Hypothetically, realistically, it would. Sorry. I just like to be extra, but continue.
Yeah, so Renisha, that looking like a clockwise moment or an anti-clockwise moment?
Anti-clockwise. If it was clockwise, it would be the other way around.
Right? So this is an anti-clockwise moment. And Renisha, if you apply a downward force,
Mm-hmm. On that side, it would go down while the other side will go up.
that looking like
And
a
that will be
clockwise.
clockwise.
Right? Clock it.
Eaten in maths and in physics too. What a happy day! Oh my god!
Check Virginia
Okay,
laughing
so
now.
continue, sir. Continue.
I feel like if you had a sibling like Renisha in your life, you'd never cry, you'd never be sad.
My little sister
Yeah.
don't think so. Little sister doesn't think so. She just call me
Oh,
Renisha is kicks, yes. Renisha is kicks. But Renisha, the good thing about Renisha, guys, only can learn from Renisha. No matter how much times you fall, you gotta get back up. Life continues. Yeah.
Yeah.
So
I've been through
Renisha,
some terrible things, but we will not speak about it.
we will not.
Continue.
But we love you and we care for you and we here for you. And, you know,
Oh, thank you guys. Don't make me cry.
and the most important thing is you're here and you're trying.
Thank you.
Yeah.
Because I
Right?
know where I want to be in life, so that's why I'm trying.
That is it. That is it. You can't give up.
Mm.
So Renisha,
Yes,
I
sir.
told you. Oh, by the way, Renisha, this is like that seesaw looking balanced or unbalanced. What do you think?
To me, well, it's not really moving on the paper. But to me it doesn't. It doesn't look balanced. It
You
looks
sure?
unbalanced.
You sure? Because I find it looking balanced. You know, I find it looking.
Oh,
like,
wait, sir, wait. Hold on. Before you say anything, I want to correct myself. Okay, you can ask me the question again, please. Let me see if I can answer it myself. Yes. That's the only way I'm gonna learn.
All right, so Renisha, is the seesaw looking like this right now?
No.
Is the seesaw looking like this right now?
Nope.
Is the seesaw perfectly horizontal?
Yes, it is.
So if the seesaw is perfectly horizontal, then then the system isn't.
Balanced?
Where's the fancy word for balanced?
The fancy word?
It starts with E. It starts with E.
Equilibrium.
Hey, W's in the chat for Anisha, guys. W's in the chat for Anisha.
Thank you. Shots fired. Was hard to take that without my mouth, but I get it.
Right? So, guys, if your seesaw is perfectly horizontal, then it is perfectly balanced. Now, I would have said that earlier, right? So, Renisha, they
Yes,
are
sir.
telling us that this system is in equilibrium. So, Renisha,
Yes, sir.
if the
Yes,
system is in equilibrium, what does that tell us?
When it's in equilibrium,
What does that tell us?
it's equal. When equilibrium means equal,
It means balanced. The system is
equally
balanced.
balanced.
So, if the system is balanced, then what do we know, Renisha?
The both sides are equal to each other.
Right. Now, both sides would generate different moments. So, Renisha, if the system is balanced, then the anti-clockwise moments would what?
Be equal to the clockwise moment.
Yes, remember this. So, Renisha, anytime a system is balanced, it's in equilibrium, the anti-clockwise moments will always be equal to the
Be
what?
equal to the clockwise moments.
Always, always,
Always.
always. If a system is in equilibrium, this will always be the case. This is called the principle of moments. The principle of moments. This is what it's called.
Principle of moments. Oh, well, you see, success never teach me that. I mean, they did, but the teacher never explained it to that extent. So, thank you, sir.
I
Thank
don't
you very
want to.
much.
Hey, Renisha, don't mention nobody. I'm thinking the next people come for me.
I ain't call no names. Name is for tombstone. I'm just saying
When
that
you
they
just
never explained it to that extent. Like you
right.
did, sir. Okay.
But anyways, Renisha, if a system is in equilibrium, then you know that the anti-clockwise moments will be equal to the
Clockwise.
good.
So I saying it wrong the whole time? It's anti or anti-clockwise?
Anti. Now you
Oh,
can say anti.
dang.
You can say anti if you want. Anti is fine. But it's not English class. It's fine. This is our math. This is our maths and physics class. So,
Hmm?
alright.
Okay, okay.
So Renisha,
Yes, sir.
what is it that we don't know in this diagram? What is it that we're missing?
What we are missing?
Yeah.
We are missing Fat Bob's mm, hold on. Fat Bob's
It's already just saying
like
fat bob boy. Don't you saying fat bob?
like the whole 5 years from the pivot. Well, he ain't that far, you
Exactly.
know.
That is what we missing earlier.
He
Earlier.
ain't
That
that
is what we
far.
are missing.
He not that
We are
far.
we missing his distance from the pivot.
Yeah. Oh God, first taking up all this space.
So
God forgive.
so Renisha, we have our equation now. Let's
Yes, we do.
calculate the anti-clockwise moment. Renisha, do we know what the distance is?
No, we don't. We don't know Fat Bob's distance. So what you
So
cried for?
you're saying fat bob.
I'm sorry. Oh Lord.
Yeah, so Renisha, if
I'm
you don't
not
know what
fat phobic, okay? Don't feel sad.
so Renisha, if we don't know what the distance is, we could just call it what? Anytime you don't know what something is, you need to
W.
assign it a variable. But I wouldn't really use W because
Yes,
W
a
means weight.
variable. This is like algebra.
It is algebra. You're forming an equation using algebra.
Oh, oh,
Renisha,
oh,
what is the best letter to use here? Real breaking up, boy.
The best letter.
Yeah. What we finding for again, Renisha?
Oh, I'm sorry. It's the internet. Sorry. We're
Renisha, what we
finding
tryna-
for like that Fat Bob.
what's another word for length?
Yes, so you hear me?
Yeah, what's another word for length?
Another word for length.
Yeah.
Distance.
Yes. So if you wanted to assign a
D.
D, yes, you could use D. No, if you wanted, you could call it X, you could call it Y, you could call it A, anything, right? But the most sensical one to say is really D, because D
R.
you find it for
R for
distance.
Renisha.
I will
Yeah.
use D because we find it for distance. So Renisha, we had to find the anti-clockwise
Listen.
moments. So we have one anti-clockwise moment and anti-clockwise moment. What's the formula for that?
Anti. This is distance, right?
No matter
So
what
what
the
it
anti-clockwise. Just tell me, what's the formula for moment?
moment. Force
Yeah.
times distance.
Right? So when we say anti-clockwise moment, it's the same formula, force by distance. So Renisha,
Yes.
do we know Fat Man Bob's force?
No.
You sure we don't know his force?
Wait. Hold on. Wait. Is the number underneath 1400 newtons? Sorry. Sorry, sir. Sorry. Sorry.
It's fine. My head is in more of it more than usual today. Otherwise I'll be a little more
I'm
patient.
I'm making your head hurt, sir.
No, it's
Sorry.
not you. I just not eating properly these days.
Oh,
Yeah. Right. So Renisha, we know that the
yes, sir.
force. Remember, moment is force by distance, right?
Yeah.
So his force is 1400 newtons. What is his distance from the pivot? What did we decide to call that?
D.
We
Because
call that
we don't know the number, so we have to put a letter to indicate
right.
that we have to find it.
Good. Let's look at the clockwise moment now. So Renisha, what is the force of Rajiv? What is Rajiv's force?
630.
And we're gonna multiply that by what?
1 meter.
Right. On the left hand side, that's gonna be 1400 D.
Yeah.
And on the other side is gonna be what's 630 by 1? What is 630 by 1?
630.
So
When
how
you
am I gonna
multiply a number by 1, it does always be the number itself. It don't ever change.
right, because 1 is the multiplicative is the identity for multiplication.
Yeah.
Yeah. So we have 1400 by D is equal to 630. What to do?
Newtons.
But Renisha, I'm trying to find for D. I'm trying to find the
Oh,
distance
right. Oh, okay. So, um, 1400 D is equal to 630, right?
right? And we're trying to find for D.
Sides by the number.
So that again?
Wouldn't you have to divide both sides by the number?
Yes, W's in the chat for Renisha. So I'm gonna divide both sides by what?
1400?
Yeah, because you have to cancel off.
Yeah, the cancel off.
Right. So what is 630 divided by 1400?
Okay, 630 divided by 1400, and we will get 0.45.
Badness. And since that is distance, that what would be the unit for distance?
The unit for distance,
Yeah.
um, meters.
Meters? Yeah, it is meters. The SI unit for distance in physics is meters.
I said that at the top of my head, I said, I don't want to wait till somebody else say it, and then I say,
Nah.
oh, yeah.
So let me just run through back these steps, Renisha. So
Okay, so let me see if I can explain it to people
talk
and
to me.
them.
Talk to me.
All right.
What was the
Hello,
first thing
TikTok.
we had to do? What was the first thing we had to do? Talk to me. Explain it to
We
them.
had to find
But wait, before you do that, look at the followers, guys. Look at the followers.
6, 7. All right. Okay, now let me go back in my full student
You're
mode.
in Renisha mood right now. You're in Renisha mood
Yes.
right now.
All right. So the first thing we said was the system is in equilibrium, right? Which
Right.
means the both sides are equal. Well,
Say the
not
proper
equal.
thing. Say the proper thing. That means that what is equal to what?
The anti-clockwise is equal to the clockwise.
Right. W's. Oh, they had a hype up Renisha, you know. W's in the chat for Renisha.
So therefore, we have to find the weight
right. So we gotta find the weight. Yeah.
of fat man Bob.
Mm-hmm.
Okay. So in order for you to find the weight, which is a force, you have to multiply mass by gravity.
Mm-hmm.
Which in Fat Bob's case is the 140 kg times the 10 minutes meters per second squared,
Right.
which would be 1400 newtons.
Good.
Right?
Yeah.
Then after that, so you can scroll down, please. Thank you. Then after that, we have to find what is Rajiv's zone. Okay? So we have 63 kg, and his distance from the pivot is 1 meter, right? So in order for us to find Rajiv's zone, you have to multiply 63 by 10 meters per second squared. I think you're correct. Sir? Hello? Hello? So here, man.
I think it's his Wi-Fi.
Yes, the
Yeah, on TikTok too. I think it's his Wi-Fi.
Oh dear. Oh dear. Hi guys. How am I doing so far? Be
Very well.
truth.
Excellent.
Thank you. I'm trying.
Yeah, you're doing great.
Thank you. Thank you. Y'all, I wonder if Certified's dead or something. Well, I don't know if it could be because I saw a notification that he
Oh, sis said he has to use his data. So like the internet went out. So like
was live.
yeah, he's making something to eat right now. But like I think the live for physics done, and he said to big up you, Renisha. You can check it out on TikTok.
Okay,
Yeah, his
okay,
internet went down.
okay.